Have you ever looked up at the night sky and wondered what secrets those distant stars hold? Astronomers, peering through powerful telescopes, sometimes see things that defy belief. An object moving faster than anything should, faster even than light itself. Is this possible, or is the universe playing tricks on us? Here on Earth we have speed limits for cars and planes. The universe has its own, the speed of light. Nothing with mass can break it, or so we think. So what happens when we see something that too? Is our understanding wrong, or is there a clever explanation? This isn't a small error. These are observations that challenge our deepest understanding. Scientists are left scratching their heads, questioning the very fabric of space and time. What could this object be? How is it performing this impossible feat? The universe is vast and full of surprises. This mysterious, speedy object is one such surprise, a cosmic dare to our knowledge. It beckons us to explore further, to understand more deeply. So buckle up, space fans. We're going on a journey to the edge of known physics, where the impossible just might be possible. Let's dive in. What exactly is the speed of light? Imagine the fastest thing you can think of. Light leaves it in the dust. Light travels at about 186,282 miles per second. Fast enough to circle Earth 7 times in a single second. This isn't just any speed, it's the universe's ultimate speed limit. It's a fundamental constant of nature, woven into the fabric of reality. Einstein's theories of relativity are built around this speed, denoted by c. All massless particles like photons travel at this speed, and nothing can send information faster than c. Why is this so important? Because space and time are connected. Space-time, the speed of light, is the rate at which events can influence each other. If something could travel faster than light, it could, in theory, travel backward in time. Imagine receiving a message before it was sent. Cause and effect would unravel. The universe seems to prefer order, so this speed limit is a big deal. It's not a rule you can bend, it's a law of physics. It underpins our understanding of energy, matter, and gravity. From how stars shine to how GPS works, light speed is at the core. Breaking it would mean rethinking everything. It would shake the foundations of science. That's why these observations are so shocking, and why they matter. Why is faster than light travel considered impossible? It's not just about building a faster spaceship. Einstein's special relativity says as an object with mass accelerates, it gains energy and relativistic mass. The closer it gets to light speed, the heavier it gets, approaching infinity. To reach light speed, you'd need infinite energy, more than exists in the universe. For anything with mass, light speed is a cosmic wall. Then there's time. The faster you move, the slower time passes for you. For a photon, time stands still. If you could go faster than light, some theories suggest time might flow backward. That leads to paradoxes, like the grandfather paradox, where cause and effect get tangled. If you could arrive before you left, logic breaks down. Faster than light travel could unravel causality, the principle that cause comes before effect. The universe doesn't seem to like paradoxes. It prefers a consistent story. That's why the speed of light is more than a number. It's a safeguard for reality. So when we see something apparently breaking this rule, it's a big deal. It forces us to question everything we know, and it opens the door to new mysteries. That's the heart of science, and the thrill of discovery. So where did this speedy object show up? Astronomers often find such mysteries in extreme cosmic environments like the hearts of distant galaxies. Many galaxies have supermassive black holes at their centers, devouring matter and spewing out jets of material at nearly light speed. Our mysterious object X was detected near one of these jets, possibly a blob of plasma within it. Astronomers use powerful tools, not just optical telescopes but radio telescopes and techniques like very long baseline interferometry, or VLBI. VLBI combines signals from telescopes across Earth, creating a virtual telescope the size of our planet. By observing Object X over months or years, astronomers track its movement, measuring its angular displacement and knowing the distance, calculating its apparent speed. It's like watching a car move down a distant road and estimating its speed, but sometimes the numbers don't add up. The calculated speed comes out too high, even higher than light speed. This is exactly what happened with Object X and with other objects in quasars and microquasars. These aren't faint, distant whispers, they're energetic, bright, and clearly moving. The data is solid, the challenge is explaining it. Are we seeing something truly impossible, or is there a trick of perspective at play? These questions drive astronomers to dig deeper, because when the universe throws a curveball, science steps up to the plate, and sometimes, the answers are even stranger than the questions. That's what makes this mystery so compelling. It's not just about one object, it's about the limits of what we know. And what we might discover next. The universe is full of surprises, and Object X is one of its best. When scientists first calculated Object X's speed, the reaction was shock. 5 times the speed of light? The first instinct? There must be a mistake. So, they checked the math, the data, the equipment, again and again. Science is cautious like that. But what if, after all the checks, the result still stands? The object to be moving faster than light. This is where the real puzzle begins. It's a direct contradiction to Einstein's cosmic speed limit. It demands an explanation. The initial reports of such FTL or faster-than-light motion were met with skepticism. Extraordinary claims require extraordinary evidence, but as more of these objects were found, the phenomenon became harder to dismiss. They were seen in different types of celestial objects, from distant quasars to microquasars in our own galaxy. The pattern suggested something systematic was happening, or a very clever illusion. Our theories say, "Thou shalt not exceed c." Our observations say, "Look at this thing go." This kind of tension is fantastic for science. It means there's something new to learn. Either our observations are misleading us, or our theories need an update. Or maybe, just maybe, the universe is stranger than we ever imagined. So, if Object X isn't really breaking the light barrier, what's going on? The most accepted explanation is a kind of optical illusion, superluminal motion. It happens when an object moves very fast, almost at light speed, at a small angle toward our line of sight. Imagine a jet of plasma shooting out from a quasar, pointed almost at us. The jet fires blobs of material, each sending light toward us. Because the jet is moving so fast toward us, the light from later blobs has less distance to travel. This catch-up effect compresses the apparent time between events, making the blob seem to move faster than it really is. It's a trick of perspective and light travel time. The object isn't violating any physical laws. This effect is well understood in astrophysics, a consequence of Einstein's relativity, not a violation. The math and geometry create the illusion of superluminal speed. For this to happen, the jet needs to be moving over 90% the speed of light and be oriented within a few degrees of our line of sight. These conditions are met in many quasar jets. So, for most observed superluminal objects, this is the leading explanation. No new physics needed, just clever old physics. Sometimes the universe's best tricks are the ones we already understand. But what if the illusion explanation doesn't fit every case? What if we find an object where superluminal motion can't be explained away? This is where things get exciting for physicists. Could there be phenomena our current theories don't account for? One idea involves the expansion of space itself. Distant galaxies recede faster than light, not by moving through space, but because space itself expands. This doesn't violate relativity since it's space stretching, not objects moving. Could Object X be related to some extreme space-time expansion? Unlikely, but it's an idea. Other exotic ideas include wormholes, hypothetical tunnels through space-time that could offer shortcuts, or new types of particles that don't interact with light in the usual way. These are highly speculative, with no direct evidence yet, but they fuel the imagination and drive the search for new physics. Even if Object X turns out to be an illusion, investigating it pushes our theories to their limits. Sometimes those limits reveal cracks where new understanding can take root. The universe is a big place, full of surprises, and physicists love a good surprise. Imagine for a moment what if Object X or some future discovery really is moving faster than light. Not an illusion, but true FTL travel. The implications would be staggering, revolutionary. Our understanding of the universe would be incomplete, maybe even flawed. Einstein's theories would need revision or replacement. If we could harness FTL phenomena, interstellar travel could become possible. The vast distances of the cosmos might become traversable. Humanity could spread among the stars. But FTL travel is deeply linked with potential causality violations, maybe even time travel. Could we send messages or ourselves into the past? The paradoxes would be mind-bending. Perhaps there are natural laws that prevent paradoxes even with FTL, or maybe our understanding of time is too simplistic. Discovering true FTL motion would be a profound shift like Copernicus Newton or Einstein's revolutions. It would energize science for generations. New theories would bloom, new experiments would be designed. The universe is always more wondrous and surprising than we imagine. A true FTL object would be a key to unlocking deeper secrets. So what's the final word on Object X and its impossible speed? In most cases, the superluminal illusion explains it. It fits the data and aligns with known physics. But science never truly closes a door. We keep observing, keep questioning. What if a new object appears that defies explanation? That's the beauty of science. It thrives on mystery. Each puzzle is an invitation to learn more, to push the boundaries. The universe is dynamic, evolving, and often baffling. Every time we think we understand, the cosmos throws us a curveball. These mysteries are not failures. They're the driving force of science. Whether Object X is a trick or a hint of new physics, the quest sharpens our tools and refines our theories. It reminds us of the humility needed when facing the universe. We are explorers on a tiny speck, looking out at an immense ocean. There will always be new islands of knowledge to discover. The story of science is a story of continuous discovery. The cosmos awaits. Keep looking up and keep asking questions.